Radioactive decay occurs when unstable nuclei release particles or energy to become more stable. Today we'll explore 5 main types: alpha, beta minus, positron, electron capture, and gamma decay. Let's break them down step by step. First, alpha decay. In alpha decay, the nucleus emits an alpha particle, nucleus of a helium-4 atom with 2 protons and 2 neutrons. This usually happens in heavy nuclei with an atomic number greater than 83. For example, polonium-210 undergoes alpha decay to form lead-206. Polonium-210 emits an alpha particle and becomes lead-206. The atomic number decreases by 2, the mass number decreases by 4, and the neutron-to-proton ratio increases. Think of it as the nucleus throwing away a heavy chunk to stabilize itself. Mnemonic to remember: alpha equals away. Next is beta minus decay, also commonly known as beta decay in many books. Here, a neutron converts into a proton emitting an electron, called a beta particle, and an antineutrino. What is an antineutrino? It's a very tiny neutral particle with almost no mass that carries away some energy and momentum during beta decay. It hardly interacts with matter, so it passes through almost everything undetected. An example of beta minus decay is iodine-131 decaying to xenon-131. The atomic number increases by 1, but the mass number stays the same. Beta minus decay occurs in neutron-rich nuclei. Essentially, the nucleus is balancing its neutron-to-proton ratio by turning a neutron into a proton. Mnemonic: neutron becomes a pro and lets an electron go. Now, positron emission or beta plus decay. In this case, a proton turns into a neutron, emitting a positron and a neutrino. Neutrinos are like antineutrinos, but with opposite properties. They're also tiny, neutral, and almost massless, carrying energy away from the nucleus during decay. Conversion of oxygen-15 into nitrogen-15 is an example of positron emission. Its atomic number decreases by 1, but the mass number remains unchanged. This occurs in proton-rich nuclei. Think of it as the nucleus shedding excess positive charge to become more stable. Mnemonic: positron means proton lost. Closely related is electron capture. Here, the nucleus captures an inner shell electron, combining it with a proton to form a neutron and emits a neutrino. Potassium-40 is an example, transforming into argon-40. Like positron emission, the atomic number decreases by 1, mass number stays the same, and the neutron-to-proton ratio increases. And just like positron emission, electron capture also happens in proton-rich nuclei. Mnemonic: electron capture equals eat. The nucleus literally eats an electron. Finally, gamma decay. After alpha or beta decay, the nucleus may be in an excited state. Gamma decay occurs when it releases excess energy as a gamma photon, high-energy electromagnetic radiation, without changing the number of protons or neutrons. Cobalt-60 emits gamma radiation as it moves from an excited state to a stable state. Mnemonic: gamma equals glow. Only energy is released, no particles are lost. To summarize, alpha decay, heavy particle away, Z-2, A-4. Beta minus decay, neutron becomes proton, Z+1, A same, emits antineutrino. Positron emission, proton becomes neutron, Z-1, A same, emits neutrino. Electron capture, nucleus eats an electron, Z-1, A same, emits neutrino. Gamma decay, energy released, no change in Z or A. By understanding these 5 types of decay, You can track changes in atomic number, mass number, and neutron-to-proton ratios.